Hello students. So today's topic is concept of algebraic identities blended with important CBSE 10th board questions. Okay. So we will use algebraic identities in order to solve CBSE 10th board questions. Okay. Which is the most important questions of CBSE and it is repeatedly asked in CBSE. So how CBSE is using algebraic identities in their exams, we will understand this one. Okay, so firstly we will go what are the important algebraic identities, and these important algebraic identities are this one. Okay, first is, you all know that a plus b ka whole square and a minus b ka whole square. In that last four, a cube plus b cube is equal to a plus b, a square plus b square minus ab, and a cube minus b cube is equal to a minus b into a square plus b square plus ab is the most important one. With that, many questions has asked in CBSE board. Okay, some questions is asked with the last two properties, like if a plus b plus c is equal to 0, then a cube plus b cube plus c cube is equal to 3abc, and a square plus b square plus c square is equal to ab plus bc plus ca, then a is equal to b is equal to c. These two properties is asked in CBSE, but it's not that frequent. Okay, rather than that, a cube plus b cube and a cube minus b cube are frequently asked. Okay, so we will learn how they are using algebraic identities in our chapters. Okay, so let's start with the first question. First question is nothing but what? A plus b ka whole square minus a minus b ka whole square. Let's go with the algebraic identities formula. A plus b ka whole square, we all know that this one. A minus b ka whole square, we all know that this one. So if we are adding this one, what we are getting? A square plus b square plus 2ab, and a square plus b square minus 2ab. Okay, if we are adding this one, what we are getting? What? 2a square plus b square. Now again, if we are subtracting this one, what we are getting? A minus b ka whole square is nothing but what? Whatever with the similar terms will get eliminated, whatever with the dissimilar terms will get added. So what are these dissimilarities in that? Plus and minus. Okay, so dissimilar term will get eliminated. So here we are writing 4ab. So this is the answer of our first question. Okay, a plus b ka whole square minus a minus b ka whole square is nothing but what? 4ab. And if we are writing a plus b ka whole square plus a minus b ka whole square is nothing but what? 2a square plus b square. Get it? So let's start with the first question, which is frequently asked in CBSE. Okay, so first question is this one. The relation obtained by eliminating theta from the equation x is equal to r cos theta plus s sin theta and y is equal to r sin theta minus s cos theta. Okay, what we have to find? We have to find the relation between x square, x, y, r and s without using without and eliminate. We have to eliminate what? Cos theta and sin theta. Okay, that we have to do. So first thing, we understood that what is a question is asking. So how will we eliminate this one? We will use first thing first, we will use what? Algebraic identities, and second thing, we will use trigonometric identities. Here cos theta and sin theta is given, so which identity we will use? The identity we will use here is nothing but what? Sine square theta plus cos square theta is equal to 1. Why we are using this identity? Firstly, let me tell you about this. Why we are using this identity? Because sine theta and cos theta is given. Okay, so we can use this one. Here we can see, let's check with the options. Okay, so x plus y, r plus x. Okay, if we are adding this one, we can't get sine square theta plus cos square theta, and we can't eliminate this one. Okay, in order to eliminate this one, we have to square this one, and if we are squaring this one, we are getting what? R cos theta plus s sin theta का whole square. Okay, since see this one, r cos theta plus s sin theta, we can write it as a plus b ka whole square. It will give you what? R square cos square theta plus s square sin square theta. A plus b ka whole square is nothing but what? A square plus b square plus 2rs sin theta cos theta. Okay, that we will know. Okay, now y square is nothing but what? Y square is what? R sin theta minus s cos theta का whole square. We can write it as R sin square theta plus s square cos square theta minus 2rs sin theta cos theta. Okay, what we had already understood, if we are adding this one, so similar terms will get added, so we can write it as x square plus y square. If you are adding this one, r square cos square theta plus r square sin square theta. Okay, and 2rs sin theta cos theta and 2rs cos sin theta cos theta will get eliminated. We can write it as r square sin square theta plus s square cos square theta. So see this, so we can write it as r square will get added, r square will get common. We can write it as r square cos square theta sin square theta. Okay, and here we can write it as s square into sin square theta plus cos square theta. Okay, so which property we can use here? Cos square theta plus sin square theta is equal to 1. So we can write it as r square plus s square. So relation will be between x square plus y square is equal to nothing but what? R square plus s square. Okay, so see this question. This question is blended with what? Algebraic identities. First thing, which algebraic identities we are using here? A square plus b, a plus b ka whole square. Okay, and with that we are getting what? Some dissimilar and similar terms, and with using that we are using what? A trigonometric identity, which is sin square theta plus cos square theta is equal to 1. So see the beauty of CBSE board. They are using algebraic identities and trigonometric identities. They blended these two concepts and give you a beautiful question. Okay, so hope you understand this one. Let's continue with the second question. Second question is just an algebraic identities which is given in different form. It is written as a plus b ka power minus 1. So we can write it as 1 by a plus b plus 1 by a minus b. Okay, we can write it like this. If we are adding this one, we can take it as LCM. We are writing it as a minus b. So we can write it like this, and a plus b and a minus b. Okay, b will get cancelled. We are getting what? 2a upon a plus b into a minus b. See this one we will get. Now let's go with the third slide, which is given as a square plus minus b square is nothing but what? A plus b into a minus b. Here we are getting the similar thing. Here we are getting the similar thing, a plus b into a minus b. We can write it as 2a upon a square minus b square. Okay, so we can write it like this. So a square minus b square minus 1. So see this one we have to understand. If I am writing 1 by x, we can write it as similar thing as x ka power minus 1. similar thing we are writing here also. Okay, hope you get this thing. Okay, let's start with the second question, which is see this. Now, this is given sine theta minus cos theta upon sine theta plus cos theta plus sine theta plus cos theta upon sine theta minus cos theta. Like if we can write it as like this, a by b plus b by a is given. Okay, so here we can use that property which we had already understood in this one, a plus b ka power minus 1 plus a minus b ka power minus 1. Okay, so let's continue with the this question. Since this is given, so we can take LCM. We are getting what sine theta plus cos theta into sine theta minus cos theta. This one is given, and sine theta minus cos theta will get multiplied with this one. We are getting what sine theta minus cos theta का whole square plus sine theta plus cos theta का whole square. This one is given. Okay, see this one, this one is really important. A minus b का whole square plus a plus b का whole square. If we are adding something, what we are getting, see this one is important. If we are adding something in a minus b ka whole square and a plus b ka whole square, we are getting what 2a square plus b square. If we are subtracting, we are getting what 4ab. Okay, hope you understand whatever we had learned in this thing. We have to apply this property in this question only. Okay, so sine theta minus cos theta का whole square plus sine theta plus cos theta का whole square. We are getting what sine 2. We are writing it as 2 sine square theta plus cos square theta. Hope you understand this thing. Why we are writing sine theta minus cos theta का whole square plus sine theta plus cos theta का whole square as 2 sine square theta cos theta, and sine a plus b, a minus b is written in denominator. We can write it as like this, sine square theta minus cos square theta. Sine square theta plus cos square theta is nothing but what 1. So we can write it as 2 sine square theta minus cos square theta. Since in option, let's see the option. In option, sine theta, sine theta, sine theta, sine theta. Sine theta is given, so we can write cos theta in our answer. We have to change that thing into sine theta kind of thing. Okay, so we can write it as sine square theta, and minus cos square theta can be written as 1 minus sine square theta. Get it? So we can write it as 2 by sine square theta plus minus 1 plus sine square theta. Okay, so we can write it as 2 upon 2 sine square theta minus 1. Okay, so this is the option D. Okay, hope you understand this thing. That's how CBSE is asking question with blending with algebraic identities, and algebraic identities we mostly use in trigonometry. Here we can use we have some certain formulas like sine square theta plus cos square theta is equal to 1. Okay, sec square theta minus tan square theta is equal to 1, and cosec square theta minus cot square theta is equal to 1. These three formula. With that formula we can't use anything unless and until we will blend this formula into trigonometric identities, into algebraic identities. With that blending kind of thing, we will use some beautiful questions. That question will ask in CBSE board, NTSC, and whatever be the hardest examination which you are giving, these questions will ask. Hope you understand this thing. So this thing will help you a lot. Just go with the question, just see the question and see whatever with the algebraic identities which we are using, and see whatever with the trigonometric identities you are using. Just blend these two and get your answer. Okay, thank you.